Hello friends, welcome to Sriram's IAS. Today we are going to discuss a launch of NISAR satellite. NISAR satellite, a first joint venture between NASA and ISRO, scheduled to be launched on 30th July. In this session we are going to discuss the importance of NISAR satellite, its uniqueness, also the importance of joint collaboration between India and USA in a space sector and its impact on India's future mission like Gaganyaan. Friends, in a recent days we have seen Axion 4 in which Indian astronaut Sudhanshu Shukla have gone to the International Space Station and successfully returned to the Earth. It is also a product of a joint collaboration between India's ISRO and USA's NASA. Same way, NISAR satellite is also a joint venture and we are going to discuss its importance, its uniqueness, also how it will help India to develop its Earth observation satellite, also strengthen India's spy satellites and also India's surveillance plus weather monitoring, climate change and also disaster response preparedness. So friends, again welcome to the session. Let's start this session. So दोस्तों, NISAR, the name NISAR came from NASA plus ISRO, also a synthetic aperture radar. Synthetic aperture radar. NISAR will be a Earth observation satellite which will use advanced radar technology to map whole Earth and take images at the angle of 98 degrees. It is a first joint venture between NASA and ISRO which is based on advanced radar technology, and it is a fruit of decade-old collaboration between India and NASA. It is a milestone of technological cooperation, technology sharing plus joint collaboration between India and USA. So NISAR is a joint venture between ISRO and NASA plus synthetic aperture radar. That's what we have to remember from his name. Now let's discuss its some features. Here you can see the image of NISAR satellite. It is a slightly different from conventional satellite images that we used to see. What is the difference between conventional satellite image and NISAR's image? The uniqueness is 12-meter long antenna, mesh antenna. It will help to monitor Earth, observe Earth and map Earth using advanced radar technology. The total weight of NISAR satellite is 2392 kg. It simply means that we cannot use PSLV, which is a workhorse of ISRO. We have to use GSLV, Geosynchronous Satellite Launch Vehicle. Why? Because of weight consideration. GSLV is India's heaviest satellite launch vehicle. That's why this mission will be completed by GSLV. Now, the satellite will be placed at the altitude of 743 km and orbit here is Sunsynchronous orbit. We will discuss that in our session, that what is mean by Sunsynchronous polar orbit or Sunsynchronous orbit. And satellite will be placed at the inclination of 98.40 degree. So it will map the Earth from space and take images using different bands of frequency. In this NISAR satellite, the two bands of frequency will be used. First is Lband, NASA, and second is S-band. Here NASA means, as we know, NISAR is a joint collaboration between NASA and ISRO. So L-band technology is developed by the NASA. Same way, S-band technology is developed by the ISRO. In this session, we will also discuss the difference between L-band and S-band and what they do and what kind of images or advantages these two different frequencies have. Also, it will take 12 days to map whole Earth. This satellite will not map only India, it will map the whole Earth and it will take 12 days to map whole Earth. And this satellite has 12-meter reflector antenna which will help in radar technology. So friends, these are the features. Now let's discuss what is the Sunsynchronous polar orbit. So Sunsynchronous polar orbit, here in this image you can see a equatorial orbit. It simply means that when you put a satellite in equatorial orbit above the equator, in that case satellite will orbit Earth west to east or east to west. But when we put that satellite into polar orbit, it means the satellite will orbit Earth from pole region to one pole to another pole, like North Pole to South Pole or South Pole to North Pole. And here movement will be north and south or south and north. and it will be synchronous with sun's movement. As we know, sun also move in the same way. That's why it is called sun synchronous polar orbit. And when we put a satellite into a sun synchronous polar orbit, it will map or it will take an image of same part of earth at same time, local solar time. So जब भी सैटेलाइट को इस ऑर्बिट में प्लेस किया जाएगा, ये इमेज जो लेगा ये सेम सोलर टाइम पर लेगा, यानी 12 डेज इसको लगेंगे पूरे अर्थ को मैप करने के लिए, पूरे अर्थ की इमेजेस लेने के लिए, और वो सेम सोलर टाइम पर, यानी 12 डेज के बाद ये इंडिया से सेम सोलर टाइम पर पास होके उसकी इमेजेस लेगा. It will create an opportunity to compare those different images, which will give us a accurate data and information about the changes happened and that landscape or that places. This way. Now, this satellite will be launched on July 30, 2025, and for launching purpose, it will use GSLV F-16, GSLV, which is India's heaviest satellite launch vehicle. As we know, GSLV is a 3-stage satellite launch vehicle. In first stage, it will use a solid fuel. At second stage, liquid fuel. And most important point, which we have to remember from exam perspective, is the GSLV's third stage is powered by the cryogenic engine. It is also called cryogenic stage. In cryogenic stage, liquid hydrogen and liquid oxygen will be used to power this third phase. And this spacecraft will put NISAR satellite into sun-synchronous polar orbit, which we have discussed earlier. Now, let's understand what is mean by the L-band, which is developed by the NASA, and S-band, which is developed by ISRO. So friends, NISAR's unique feature is it will be a first satellite in the whole world which will use dual frequencies. Previously, what used to happen is that a satellite usually use only one frequency, but NISAR satellite will use dual frequencies. One is L-band and another is S-band. Now, let's discuss this. So, as we know, electromagnetic spectrum consists of radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays, of which visible light, a very small range of frequency which we human can use to see the earth or other places. In radio communication, we use radio wave, but in satellite communication or for satellite imaging purpose or satellite communication purpose, we generally use microwave. So L-band and S-band both are a part of microwave spectrum. It's a first point. Second point is it's all weather scenario. Using this microwave band, of which L-band and S-band are part, we can take images or map earth or monitor the earth in all weather scenario, day and night, and it will provide us global imaging capability, and it will map whole globe, whole earth in 12 days interval using advanced radar technology, synthetic aperture radar. Now, S-band and L-band. As we know, L-band is developed by the NASA. Its frequency range is 1 to 2 gigahertz and wavelength is 15 to 30 centimeters. Same way, S-band, which is developed by ISRO, its frequency range is 2 to 4 gigahertz and wavelength is 7.5 to 15 centimeter. As you can see, there is inversely proportional relation between frequency and wavelength. Now, look at the important feature. S-band have a very deep penetration power as compared to S-band. S-band gives us only moderate penetration. So deep penetration means it can penetrate through vegetation, soil and glacier. But the important feature of S-band is it have very good and high resolution capabilities. So by using this both frequency band, we can have very deep penetrative images plus very high resolution, good quality images. By processing these images and comparing old images, we can get accurate data which will help us to understand the landform changes, climate changes, also disasters. We can predict disaster and prepare according to. So L-band will be used in a forest, ice sheet and ground ship monitoring purpose. Same way, we can use S-band for urban mapping, agriculture, shoreline mapping or coastal monitoring purpose. So these two frequency band, L band and S band, are part of microwave band, and NISAR will be a first satellite which will use these both dual frequencies for imaging purpose. This is its advantage and its unique feature. Now let's discuss its applications. The NISAR satellite, a dual frequency satellite with L band and S band, it will provide us images, and by comparing those images we can detect ground deformation. Ground deformation where different types of landforms like landslides, cracks, earthquakes, increase in mountain heights or degradation of soil. Same way, water mapping in river, freshwater resources. We can also monitor ice sheet and glacier movement, which will help us to avoid disasters and also to have accurate data about the climate change effect on glacier system. Same way, we can use this for vegetation and forest biomass changes. By using this satellite, we can monitor forest loss. Same way, we can calculate density of forest or accurate forest area. Same way, vegetation in agriculture, what kind of crops we are cultivating, and the land which is under cultivation, we can use this technology. Same way, soil moisture analysis, monsoon forecasting, or for example drought situation. This data of soil moisture can help us to predict and accurately calculate the drought affected areas. Same way, shoreline and surface water bodies. We can use this NISAR satellite to calculate the water available in surface water bodies like lake, water reservoir, and according to that we can plan our water usage in household purpose or agriculture purpose or industrial purpose. Ice sheet classification, natural disaster response and climate modeling. By using data provided by NISAR satellite, we can create a climate change modeling and its effect and the probable disaster which could be caused due to this climate change effect, and we can prepare accordingly. So friends, these are the various applications of NISAR satellite. Now, developing this satellite, some of the organizations of ISRO have played very important role. As we have discussed that L band is developed by the NASA, S band is developed by ISRO, but ISRO's Space Application Center, Ahmedabad, played important role in development of S band synthetic aperture radar. Same way, UR Rao Satellite Center, which is situated in Bengaluru, also played important role in satellite integration and its testing. These are the two important ISRO's organization which have played important role in NISAR satellites development. So friends, in today's session, that's all we have. I hope you have found this session very informative and interesting way. Friends, you can take advantage of free one-on-one mentorship which Sriram IAS offered to you. You can click on a link given in a description. And also, I wish to share with you a Sriram's IAS new YouTube channel. Sriram's IAS new YouTube channel, Sriram's IAS UPSC Preparation. On this YouTube channel, we provide you exclusive material help regarding or exclusively helpful in UPSC preparation. Nothing else. So you can visit our YouTube channel, subscribe it, and take advantage of Sriram's free UPSC guidance program. So friends, that's all in this session. We will see in the next session with some interesting topics. Till then, thank you very much.